Greetings to the examiners. My name is Eddie Cowehan from SECRH. My supervisor is Miss Hatina binti Kutimami, and the project that I have proposed is MATLAB, Educational Escape Room, which is also known as MATLAB. MATLAB is an interactive web-based educational game that is designed to assist and enhance traditional teaching and learning methods for primary school students and educators. First, we are going to see the overview of the content that will be covered in this presentation, and here is the list. Next, for the problem background, the problem comes from the traditional teaching and learning environments. In a traditional teaching and learning environment, the educator face difficulty in maintaining student engagement. This is because the minimal classroom interaction has reduced active involvement, and over time, students will struggle to stay focused and motivated, especially in subjects that require critical thinking. Second, in traditional learning methods, it depends on rote memorization, which may result in poor knowledge retention and disinterest. It does not support the creativity or adaptive learning strategy that students often needs. Last but not least, traditional teaching and learning environments also lack interactive elements that will encourage study. Therefore, this project is aimed to design and develop an engaging and interactive educational game website that can enhance teaching and learning experience while helping primary school students to improve their knowledge retention, as well as providing educators an effective platform to monitor and assist student development. There are three objectives that will be covered in this project. The first one is to review the effectiveness of gamification learning in education by analyzing the existing educational system and game, as well as current teaching and learning process between educators and students. Second is to design and develop an online single-player educational escape room game website that enhance traditional teaching and learning environments, improve student engagement while helping students to retain learning knowledge and fulfill user requirements. The last one is to test the functionality and usability of the game website with users. Next, we proceed to the scope of the project. First, the MATLAB system is designed to be implemented at primary educational level only. Second, the escape room game inside the system will be implement search algorithms like breadth-first search, Manhattan distance heuristic, and greedy algorithm. The game inside the website also will be class-based to make it easier for the educators managing their students. Third, for the data security and privacy, authentication techniques and hashing technique will be implemented to block unauthorized users from accessing the website, as well as making user details become more secure. Lastly, the educational game will be a web-based system accessible on computers and tablets, specifically designed to teach mathematics. It features three difficulty levels, which are easy, normal, and hard, with an option for educators to create customized levels. For the literature review, I have made comparisons on three existing systems, which are Breakout EDU, Mummy Maze Deluxe, and Quizzes. Breakout EDU is a game-based educational tool that integrates academic contents while bringing the thrill of escape rooms into the classroom. The benefit of the system is it can create custom puzzles aligned with curriculum standards, but it requires significant input from educators to design and implement puzzles, which may use up educators' time. Mummy Maze Deluxe is a maze solving game that requires strategic thinking and avoid being caught by the enemy. The game promotes critical thinking as well as strengthens logical reasoning and problem solving skill, but it focuses only on maze solving with no educational content integration. Quizzes is an online learning and assessment tool which incorporate gamification components to make learning more impactful and engaging. Quizzes offer pre-made quizzes and lessons created by educators worldwide, as well as provide real-time feedback and detailed performance analytics. However, it has limited interactivity compared to immersive game-based platform. The proposed system, MATLAB, aims to enhance the limitation of the existing systems by integrating their strengths while addressing their weaknesses by combining the core elements from this platform to create a comprehensive educational game. The slides show the technologies that will be used in MATLAB, which include database, server, front-end, back-end, algorithms, network element, as well as the security elements. To ensure the project is kept organized systematically, plan-driven software development methodology, which also known as the waterfall models, is chosen for MATLAB development. This is because the structure and sequential approach provided by the waterfall models can ensure that each development phase is fully completed before proceeding to the next phase. Besides, since the requirements are clearly defined upfront, the methodology is suitable to be implemented. In phase 1, it involves gathering the system requirements through interviews or surveys with educators and researching the current students' learning process. This focus is on identifying challenge faced in traditional teaching and learning approach and understanding educators' needs. Since primary school students may not fully understand the survey, their learning preferences are derived from the research study. In phase 2, the unified modeling language diagram, which include use case diagram, sequence diagrams, and class diagram, are designed to illustrate the system functionalities. Besides, the system architecture, game mechanics, and the user interface design will also be established in this phase. Currently, we have just finished the phase, and the third phase will be proceed in PSM 2. For phase 3, which is the system development, the actual coding and development of MATLAB will be take place, which include front-end development, that is to create the interactive interface, back-end development, which is to handle the game logic, database operations, and authentication process. Moreover, algorithm will be implemented in the game to control the enemy movement and game puzzle mechanics. After the development phase, the modules of the system will undergo testing to make sure the system is stable and functional. Component testing verifies each component. Integration testing will ensure smooth communication between the front ends and the back ends. The user testing will be conducted with educators to confirm the system usability and effectiveness. For the phase of system deployment and maintenance, since MATLAB is developed only for PSM, the system will not go through the deployment phase for widespread use. The project will be concluded without implementing long-term maintenance after the testing phase. The developer's hardware is for ensuring development process runs smoothly. Therefore, there are some requirements on the hardware to develop the system. For the development machines, it must be a computer with at least Intel i5 processor, 8 GB RAM, and 256 GB SSD, or the computer with the same processor level to ensure a smooth performance during the game development, testing, and debugging. A cloud-based hosting server with a 4-core CPU, 8 GB RAM, and at least 100 GB storage will also be required to provide user a system that is scalable, reliable, and remote accessible, as well as ensure a stable operation without hardware dependency. For the software requirement, the developer's software is for the purpose of coding, debugging, and testing. The slide shows the minimum software version that is required to develop MATLAB in terms of operating system, web browser, front-end and back-end, technology, frameworks, database engine, as well as coding environment. Next, for findings, to determine the stakeholder requirements, interview and survey as well as research on the current teaching and learning environments are conducted. For the interview and survey, both questions are the same, and it has 17 questions coming from 5 parts as shown. There are 36 educators who have responded to the survey, and 3 educators are conducted with the interview sections. The insights gained from the findings are used to determine the functional requirement and the non-functional requirements. The functional requirements specify what MATLAB should perform about its features based on user needs. The functional requirements of the MATLAB system are categorized into 2 groups, which are the student requirement and the educator requirements. The student requirements are gained from comprehensive research, while the educators' requirements are gained from a series of survey and interviews. The requirements are as shown in the slide. The non-functional requirement specifies how MATLAB should perform in terms of quality attribute rather than specifying what it has to do. The non-functional requirements of MATLAB are categorized in the aspect of security, reliability, accessibility, usability, scalability, and performance as shown. The layout of the system is important to be structured well to ensure clarity, accessibility, and user engagement. A well-designed interface can enhance user experience by providing a clear visual and easy-use system. The following illustrate the interface of the MATLAB system. The first one is about the login page, followed by the main page, classroom page, puzzle creation page, and last but not least, the game page. Next, we move on to the PSM2 planning. During PSM1, progress is made in addressing the first objective, which is to review the effectiveness of gamification in education. The process has provided insights into how the game-based learning can improve student engagement, critical thinking, and knowledge retention. For the second objective, which is to design and develop an online single-player educational escape room, some achievements are met in system planning and design. The actual development and testing of the system will be conducted in PSM2. Building on the foundation established in PSM1, PSM2 will be focused on the full development, refinement, and system testing for the MATLAB system. The development phase will involve integrating the game mechanics, puzzle management, and the back-end functionalities into an interactive game platform. Moreover, the security measures such as password-based authentication and hashing will be implemented to safeguard user information. In the testing phase, it includes usability, integration, and unit testing to confirm the system responsiveness, accessibility, and performance in various situations. Upon completion, MATLAB will serve as a working prototype to show that it can be used as an interactive teaching tool in a classroom setting. To be concluded, the project has introduced MATLAB, which is persuaded by the growing needs for interactive and engaging digital learning environments. With MATLAB, it aims to enhance students' learning experience and bridge the gap between immersive digital learning and traditional classroom delivery. So that is all from me. Thank you for watching and listening.